Hello students, welcome to the physics class. For the 6th class students, we would like to go for the discussion that is related to derived quantities, and we would like to go for that problem solvation based on the derived quantities. Let's have a look. That is going to be the today's topic, just we have to take that. It's very clear. We would like to go for this one, all right. Yeah, let's go for the derived quantities. Yes, if we have that, yeah, you can take that fundamental quantities. Yes, they are going to be independent. It's very clear. So, derived quantities are going to be depend another quantities. Yes, we have to take this one depending on another quantities. Very clear. We would like to go for this one. Already we have discussed about this derived quantities, how they are going to be obtained with the help of the fundamental quantities and supplementary quantities. Just we have to take that. It's very clear. Okay, let's have the problems based on this one. Right. So, a train, which is, yeah, it's very clear. If you are going to take that physical quantities, we can get that classification. They are going to be the fundamental, which are independent. Derived quantities. If you have taken the derived quantities, while we are going to consider the motion along one dimension, all right, okay. A train is moving along one direction. Let's assume that it's going to be having that speed 54 kilometer per hour. The time taken by the train to cross the bridge of 0.4 kilometer. It's very clear. Yes, we would like to go for this one, right. Here we would like to go for that speed, it's a derived quantity, and we would like to go for that velocity. In case of 1D, both these are going to be having the same magnitude, but the velocity which is having the direction, but the speed is going to be having that independent of the direction. It's very clear. We would like to go for that path dependent and path independent. Okay. Yeah, in the given problem, we need to find out that from the given data, how much time does it took for a one train to cross the 0.4 kilometer length, to cross the bridge which is having the 0.4 kilometers. Okay, it's very clear. Now you have to get that length of the train, just you have to get the given data. You have to get this one, this is very important, which is going to cross the train, just you have to, yes, which has been crossed, all right, it's very clear, which is going to be, yes, you have to take this one, very clear, yeah. So, the train has been crossed, just the distance which is going to be identified, yes, which has been crossed. You have to consider the total distance, that is going to be, you have to get that total distance is going to be that is 400 plus 200 meter. Very clear, you would like to go for this one, all right. Okay, yeah, length of the train. You have to take, that is 200 meters, all right, it's very clear. Yes, you have to consider the total length which is going to be crossed that bridge. Whenever it has been crossed, it is used to get that 200 actual length of the train and also the length of the bridge, which is also considered. It's very clear. So the total distance covered, it is going to be identified 600 meter. It is very clear. So it is one of the important point, right? You will get that speed of the train. You have to get that the train. It's very clear. That is going to be 54 kilometer per hour. All right. If you are going to have that conversion, please get that conversion. That is going to be 54 into 5 by 18 meter per second. Yes, you have to get this one. Yeah, 15 meter per second. Okay, this is going to be the speed of the train. All right. What you would like to go for this one? If you know that, yeah, you can get that formula, use that. Yeah, you have to get. Yes, speed is equal to distance covered. Yeah. By time. You have to take that. In the given question, they are about to know about time. Just you can take. Therefore, t is equal to distance by speed. It's very clear. We would like to go for this one. Just you have to take the either distance or displacement along 1D. It's very clear. If the change is in the direction, we need to know about that there exists a difference between distance and the displacement. If it is in 1D, obviously we would like to go for 1D in case of that the problems related to train, right? Okay, yeah, that is very clear. You would like to go for this one. What is the distance travel? That is going to be the 600 meters by, what about that, 15 meter per second. That is identified. You will find out this. Yeah, 40 seconds. It's very clear. Get the answer. It's better for you, right? This is the answer. You have to take that. Everyone has to identify this. Let's have the look. It's very clear. So what they have given? They have given the length of the train and the speed with what does it moves. And that you need to calculate the time taken by the train to cross the bridge. If they have given the distance travelled and the time, you may estimate that the speed of the train also. It's very clear. Yes, let's go for another one. It's very clear. We would like to go for this concept, that is going to be, yeah, measurement of the power. Yes, if you are going to take that power, it is rate of doing work. Is the rate of doing work. Yes, you have to estimate this one. We know that power P is equal to work by time, very clear, right? You can confirm that. So, from this formula, you have to, from this triangle, it has been designed that you should know this is going to be work, this is going to be time, this is going to be the power. You will get that P is equal to W by T, PT is equal to W. Yes, it's very clear. You have to confirm T is equal to P by, just you have to take this one, W by P. All these are all the relations you have to measure. All right, it's very clear. You would like to get that here. So, you can take that power. If you are going to take that electric power, the electrical appliances are going to be execute their function. Yes. So, sometimes we need to get that electrical energy is going to be converted as the mechanical energy and heat energy. Yes. The electrical appliances are driving that conversion of electrical energy into another energy by means of mechanical energy or heat energy, whatever. Okay, all right. So, you can get that power, and the time it's going to be what you have to, yes, you can take that time is going to be second or in terms of hours also. Just you have to get that kilowatt hour. Just you have to get that. Sometimes we can use that kilowatt hour. The power consumption and the related problems are going to be getting that kilowatt hour. They are going to be expressed watt second. So, okay. If you are going to have that high magnitude, just you have to take that kilowatt hour. With respect to the time, you need to get that measurement of the power consumption and the billing and all these related problems, you have to take that. Yes, if you have taken that one appliances, if you have taken that motor, it consumes that 2 kilowatt hour just per hour. If it is going to be running at 3 hours daily, you need to calculate that for 1 month, for 30 days. They have given the date also. Just you have to multiply number of days into number of hours it has been worked, and you can do that the power consumption and get that billing rate also. Number of units that has been obtained. So, it is going to be the work done. These are all the derived units. All right, it's very clear. We would like to go for these derived units, and we can express all these things, right? So, in case of a person has been lifted that weight, you need to get that work done by the time. Just you have to take. If you are going to get that a motor which is going to lift the water from the deep well, yes, it's going to be, with respect to time, how does it will lift the water and amount of water which has been lifted. You need to estimate all with respect to the time. That's what you have to get, that power is equal to rate of doing work. It's very clear. Now, let's go for this one. Yes, electric meter measurements, or electric meter measures the amount of electrical energy in kilowatt hour. It's very clear. Kilowatt hour. Just you can take this one. This is very clear. We would like to get that watt hour. So while you have taken that watt, just you have to consider that time. It's going to be the second. It's very clear. It's very minute. All right. Okay, while you are looking into this diagram, just you have to see, you are having that measurement, you are having that some microscopic phenomenon, it's very clear. You would like to go for this, the electrons which are revolving. Do you know these are all electrons? Just you have to take that electrons. Yes, it's going to be revolving in its orbit. Just you have to take this one. Very clear, we would like to go for this one. If you want, just you have to draw it. Yes, if you are going to get this one, so its path is going to be defined. Right. So you have been considered that this is going to be the radius. All right. This is going to be the nucleus. It's very clear. Now I am telling you the heat or the energy which has been transmitted in the matter, which has been identified. The microscopic particles plays a vital role for the macroscopic change. Heat is transmitted. It's very clear. These microscopic particles transmit the energy, transmit the heat energy, transmit the electrical energy, transmit the mechanical energy. Just you have to see. For the macroscopic changes, microscopic phenomena was the responsible factor. All right, it's very clear. Okay, what about our measurements, our derived quantities and all these things you have to consider. So its radius is going to be measured with the help of this. Yeah, we have to take this one. Yes, radius, which has been measured in terms of angstrom units. Just you have to get that angstrom units. All right, it's very clear. Okay. Here we would like to talk about that energy. Yes, if you have taken this one, just you have to see this is going to be in the case. So the electron which is going to excite or de-excite from one orbit to the another orbit, you know that there exists a energy. You have to measure it, that electron volts. Yes, if you are going to get that potential energy, that is going to be charged into, yeah, it has been accelerated and it has been E. This is very clear. This is going to be that potential. This is going to be the charge. We can measure the different parameter, we can measure the different derived quantities with the help of this microscopic phenomenon. When electron is used, electron is going to excite or de-excite, the minimum amount of energy required by that electron. So it has been expressed in terms of electron volts. All right, it's very clear. Okay, if you are going to get that, yes, 1 electron volt, just you have to get this one. Yeah, electron EV, just you have to get that. In order to, just you have to take that, in order to displace the charge of 1 coulomb through a 1 unit distance, that energy which is going to be taken, right? You know, QV, just you have taken that 1.6023 into 10 to the power of minus 19 coulomb. you have taken in 1 volt. It's very clear. So it has been expressed in terms of joules. It's very clear. All right. It's very simple to solve the problem. All right. While if you are going to learn potential, just you have to take this one. This is very clear. Yeah. This is a Q charge which is going to be, yes, which has been displaced a distance. So you can confirm that V is equal to W by Q. Yes. So W is equal to VQ. So this is going to be work done. This is going to be the potential. This is going to be the charge. It was going to be getting that joule or electron volts. That is going to be equal to the V and Q. Easily we can measure that. From this one you can have that measurement of the derived quantities. It's very clear. You would like to get this one, right? Let's go for the problems. Yes, what we have discussed, all right, it's very clear. So do you know 1 angstrom unit? It's very clear. 1 angstrom unit is equal to, yes, you have to take that 1 angstrom unit, that is going to be 10 to the power of minus 10 meter, that is equal to 10 to the power of minus 8 centimeter. Yes, you have to take this. All right, it's very clear. You would like to go for that first one. This is going to be the correct answer, and this is also going to be the correct answer. You agree? Right. Let's go for that 1 mile. If you are going to take that, 1609 meter. Just you have to take that. So 1600 meters nearly. 1.6 kilometer. 1.6 kilometer is equal to 1 mile. It's very clear. Yes. This is going to be that correct answer. Yes. Okay, the light year we are going to get that the distance traveled by the light in 1 year. Just you have to take that. This is very clear. So we would like to go for this one. Yes, if you are going to get this one, 9 point, just you have to take this one. If you have taken that distance traveled by the light in a 1 year, that is going to be 9.467 into 10 to the power of 15 meter, right? That is light year. You have to get this one. So light year, it's going to be identified that distance traveled by the light, in 1 year. Yeah, it's going to be 9.46 into 10 to the power of 15. Yes, you have to take this one. So 9.46 into 10 to the power of 15 meter. That is 9.46 into 10 to the power of 12 kilometer. So you can estimate that 9.5 into 10 to the power of 12 kilometer. It's very clear. All right, you would like to get this relation. Okay, you have to, just it is going to be matched with this one. Okay, all right. 1 bond, it's going to be the new term. You are going to get this one, all of you. 1 bond. What do you mean by that 1 bond? Yes, we have taken that. Yes. So you have taken, that is going to be that 1 atom. Yes. yes, 1 born. If we are going to take this one, just you have to take that. This is going to be the atom, this is going to be the nucleus. Yes, the nucleus cross section area, yes, you have to take this one. This cross section area, what I am going to tell you, that cross section area which has been measured in terms of Born, yes, it's going to be area, it's going to be getting that this cross section area. It has been 10 to the power of minus 28 meter square. Cross section area, all right, this is going to be clear. So, this is the new concept for you. You would like to know about that microscopic parameters all. Let's go for another one. Easily you will solve the problem velocity of your body moving with uniform acceleration 2 meter per second, 10 meter. Its velocity after time interval, yes, what they have given. You have to take that. So, u is equal to 10 meter per second. It's very clear. A is equal to 2 meter per second square. V is equal to question mark and t is equal to 4 seconds. You know, V minus u by A is equal to t. So, you will get that V minus 10 by 2 is equal to 4. So, V is equal to 10 plus 8. You are getting this one. That is going to be 18 meter per second. You can easily solve the problem, all right. Just have the look into that matter, you can easily understand this one. Yes, everyone has to do that. This is very simple problem for you. You can get that measurement of velocity. Just you have to take this one. This is very clear. You would like to go for this one. So, it is moving with an initial velocity u. It is going to be having the final velocity in the time t is equal to 4 seconds. What is its velocity? Just you have to find out that. Meanwhile, you should get that acceleration that is going to be uniform, that is u is 2 meter per second square. In this way, you will solve the problem. Right, it's very clear. Yes, you have to take that. That implies V minus 10 is equal to 8. So, V is equal to 8 plus 10, that is going to be 18. So, V is equal to 18 meter per second. This is the option that we have to choose, that is D, all right. So, we can solve the problems very easily, all of you. So, velocity depends, if you are going to get that derived quantity, acceleration, velocity, initial velocity, final velocity, all these are going to be dependent factors. Yes, you have to take that, it's very clear. So, velocity, it depend on displacement and time You are going to get that acceleration, all right, you can get this one. It depend on the rate of change of velocity. Okay, students, we would like to discuss about more all these concepts in the coming classes. Thank you very much. Have a nice day.